Alright guys, in this part we'll make an enemy object, like O player or enemy that keeps spawning every time someone new joins our server, other than this player itself. So let me just duplicate O player and call it O enemy, but it won't be anything, events would be totally different. I'll show you guys. You don't need a step event really, unless you need more logic. Even async networking is not needed because we have one object that handles all of that. So in create event, what do we need in an enemy? We need a unique identifier, right? So let me just call that enemy ID. This is like the client ID. You know what? Client ID is better instead. Client ID equals 0. And I'll give another variable for the username. So call that enemy username equals, for now, let it be an empty string. Okay, cool. Now let's go to Visual Studio and code this part. We will need to dynamically create and destroy enemies you know, as they are dead and alive on the server, and we'll also have to change their position. So for that, let me just make a new function in JavaScript called function state update. This is like this function updates, this function will send updates about everything on the server to everyone. So that's it. It's really useful. And to do that, first we'll say um, for let I in players. So now we have taken one player. Wait, let me just take the player first. Let's take var player info equals um I'll make this I'll give the player's x coordinate. I'll give you have to give everything about the player. So let's say ID, and I'll call this players I dot ID, then x players of this dot x, sorry, player I dot x, same for the y, players of I dot y, and then at the end, what else do we need to send? Okay, let's just send the name. Yeah, so name, got it. So this JSON object is like, everything about this player that everybody else should know. And we will now we have this player's info. Let's send it to everyone else. To do that, we need another for loop for let j in players. Um, Now, in this loop, we have to take every player's socket object, every player's WebSocket instance. And how do we do that? We take players j, so we have selected the player now, dot socket object, we have selected the socket object now, dot send. So we have selected the function. Now we can send anything. We can send hi. But in this case, what we are sending is this, state update. In fact, it would be better to say player info for state update. And let me just put the event name here as um, state update. So state update. And yeah, now we'll JSON stringify this and send it to this. So we're taking the ith player's information, and here we're sending it to the jth player. This happens, it's like a double for loop. And let me just say JSON dot stringify. What's that? Players. Oh my god, please don't name your variables this way. But I hope you guys understand it. This way, this is being sent to every player. Now let's see how this is going to be handled. To handle this, we'll go to our async networking event. We'll have to create another case here. This is state update. Case state, oops, sorry, state, and now what we will get in the state update, what do we get here? We get a particular player's ID, the X name, and yeah, the event name. So for that, um, let's do var enemy ID equals the real data ID. Yes, and even we can make variables for enemy X. It would just make stuff a bit easier for us. Similarly, one for Y. So the name thing is not so useful right now. I mean, you can add the name too, but for now let's just ignore it. It doesn't matter. Okay, this is X, not yeah. So for now we have all this, and let's create a variable called found, and I'll tell you guys why we are doing this. Found is equal to false. So now what we'll do is, we will have many enemy instances in our game, but when a new player joins the game, we don't have an event for that. So we'll have to check if the information we have received for the player is a player that exists or a player that does not exist on our screen. You get it? On our screen. On the server, everybody is there, but on our screen, they may or may not be there. So this is like, ideally we should have a create player event, but here we are doing it this way because time crunch. So let's do with ONEB. So if we actually have an ONEB here, and if we get if enemy ID equal to client ID. So we're looking at this enemy object and checking if we have found this, this particular enemy whose state update we have received. If we have found an enemy, it's good for us. We have found, so we say found equals true, and we can, change the X and Y coordinate. So X equals enemy X and Y equals enemy Y. By the way, I'm kind of sorry if you guys get a bit of disturbance in this video. I'm not in the best of environments right now. So noise wise. So okay. Now in this case we have found the enemy, so all's good. But what if this is a new player whom we still have to create an enemy instance for? In that case, the variable found would still be false. So if not found, then we would say, you know, instance create layer, and you can initialize it to 0 comma 0 because it'll anyways get another update and change itself. So 0 comma 0, and the layer name is the default layer name was instances, right? Instances and ONE. But what is important here is we tell we'll give this enemy its client ID. That's how we identify them. So we say var enemy equals this, and enemy dot client ID equals real data ID. So if the player does not exist on our world, in our local world, we are creating him, and if he does exist, we are changing his X and Y. You can also, you should ideally put the name here too, and you can put the name. It's not a big deal, but for now, let it not be there. Okay, so we have done this. Now let's make this a recurring event. This should be, this whole thing, this sending thing should happen once every frame. And what's the equivalent of once every frame? Once every 16 milliseconds. That's actually a lot, but let's see. There's a function here called set timeout where you can, call a function with every, you can call a function in 1 second. So first you give the function name, and then I guess you give in how much time you want to call the function, right? Yeah. And this is in milliseconds. So if I say 1000 by 60, I'm calling this function in 1 frame. Okay, you guys get it? And yeah, you know what? Let's just make this easy. I'll call it every 20 milliseconds. Cool. And I hope my format is right. And now we'll call state update once. So what's going to happen is we have defined this function. So when our code goes down this way, it'll call this once. And because of recursion, because we have set timeout inside this function again, it'll keep calling it every 20 milliseconds. You get it? Good for us now. I think we have pretty much done everything. So let's launch this. Right click shift node server.js. Now again, HTML5 is okay, really. Okay, there is one thing we might have missed. Um, so you guys know here in this function, this is really interesting, really. When let's say we have a player Jake, okay, he's the first player. So for I in players, if this is Jake's players information, and we have another for loop here. So you're taking Jake's socket object and sending him Jake's information. So it's kind of a repeat. You guys understand what I'm saying? You don't want to send Jake's update again. And actually, there's a very simple way to deal with that. Um, if not found, we'll actually have to say if real data of ID, if this is not equal to global dot client ID. So if this is not us, only then we want to create somebody here. You guys get it? Jake does not need to create Jake as an enemy. But other than that, everything should work normally. So just put that aside and oops, did I screw it up? Sorry. If I have screwed it up, let me just run it again. Again, this is the Notion page. Uh, you guys can like there is the link in description for this page, and you guys can copy the code from here. Okay, and one more thing, you have to also deal with repeated instances. So let me stop the node server and run the server again, minimize the server, and let me just call this guy Jake. Okay, now Jake is not created again, that's why it's not that double thing. Next, let's have another instance here. We just call this Alan. Okay, and okay, Alan is not showing on Jake's screen. Alright guys, so I figured it out. It was actually working, but I'll tell you what happened. Basically the connection got timed out for some reason. I don't know why, but it did. So in one tab it got timed out. So if I restart it here and say Jake and here, okay, Alan. So you guys can see Alan is appearing on Jake's screen, and there is a good bidirectional communication happening, which makes our whole thing work. And in fact, we kind of have a pretty, not it's not pretty, but it is a working game. Okay, and let me just show you guys how you can make it even faster. So, oops, yeah. So let's see how you can make it faster. And one really cool way of doing it, which is very simple, is called this is called interpolation, and you guys would have studied it in a STEM course probably. So the way to do that is, here we're setting x to the x we receive from the server. So instead of doing that, let's just say let's set x to the current value we have, half of that value plus half of the server sent value. What this does is it makes the movement a lot more, smooth this way, and you guys will be able to see the difference. That's one change we'll do. And here, instead of calling it every 20 milliseconds, let's call it every 16 milliseconds. That's perfect. That's not perfectly 60 FPS, but it is okay. So we save it and run this node server again and run this again too. This no. So let me just call this J and another one for Charlie. And now you guys can see, even though I'm in Charlie's tab, it's moving really fast, and the movement is pretty smooth for Jake. See that. In fact, you can experiment with different interpolation values here. Just gotta make sure, if this is 0.3, you wanna make this 0.7. This would be even smoother movement because you're trusting, okay, no, this would be less smooth. This would be extremely smooth movement because you're trusting your client side information more and you're trusting the server side information less. So it's smooth. This is the whole concept of interpolation. But you can, yeah, you guys can see we have actually created a pretty simple game for two, and yeah, we've done it fast too. It's literally not even 2 hours, I think, in the whole series. So yeah, in the next part we'll probably look at handling dead players instances. For now, if I close this, it's that guy has not disappeared from here. So we'll see how we can handle that.